Hi guys, how are you all? Ashita, what are you doing in school, Ashita?
In school, we are doing rate of change of like quadratic and like we're trying to identify if it's like quadratic or linear based on the rate of change.
Easy, right? Whatever
Yeah.
we have discussed, right? Yeah. See,
Yeah.
the AP pre-calc is just blind. Everybody does the same.
Hmm.
Okay, and the benchmarks are too outlined very narrowly. Okay, but honors pre-calc was really good curriculum. I don't know why they destroyed it. Hi, Akshada. Did the school start? Oh, you're on mute and you're talking.
Yeah, school started.
So, how is it? I am curious to know. How is
It
the change?
it's okay. It's not bad, but it's not good.
What do you mean by that? Why?
Like the school's like average. It's not like great, but it's not like a terrible school.
Okay, did you get the Frisco transcript for
Yeah,
algebra?
I got my credits.
Oh, good. So you're in pre-calc class?
Yeah,
Do they teach AP pre-calc or honors pre-calc?
AP.
AP, okay. So you're in the AP pre-calc class, is it?
Yeah.
What did they get you started with? I'm just curious.
I think we're doing like concave uh
Concave up and concave
yeah,
down. You
concave
remember
up
when
and
we
concave
discussed that?
down. Yeah, I remember doing it.
Okay,
So it
so it
wasn't
was
that hard.
okay, good, good. See, but see, I'm glad, if you were, if you had been in algebra 2, it would have been so different between common core and non-common core. Now, if you're in AP pre-calc, it's all one and the same. Very blind, same benchmarks, same content everywhere. You got it?
Yeah.
Even the exercises will also come from College Board. So it's pretty a direct curriculum. That's nice. Okay. Annam and Advait, how are you feeling, guys?
It's pretty easy right now.
What are the
Um,
discussion, rate of change?
yeah, average rate
But
of
you guys did
change.
not attend those classes with me, right?
Yeah, but
But
it's
you're able to
like,
catch up.
yeah, it's like mostly algebra and algebra 2.
Okay. Sahana, wonderful to see the performance, some test performance. I was so happy to see from your mom. Were you happy?
Yeah.
Good to see. Sricharan and Shrikar, how is it going?
It's fine. We're just doing like concave up and concave down. Like,
Concave down. Okay,
Yeah,
I think it's
same
the
for
same.
us.
Oh, okay, okay. Shreya, the same thing for you? See, that's what, see, the benchmarks are so blindingly the same. So it might be same exercises you might be doing too. It will be very similar. We'll go ahead. Okay. Um, what is this? 1 second, guys. I don't know what I'm doing with this. 1.9 second.
Miss Priya, I was wondering when we would finish Unit 1 in this class.
Um, Unit 1 may not finish in this class. 1 second. 1 second. Let me answer that. Let me save this. Okay, and then answer your question.
Okay.
1.11. 1.11. Okay, I'm good. Will I finish? Let's see. Let me tell you that as well. Okay, I'll open a new one. I'll first share the screen with you guys. Mm, will I finish Unit 1? I doubt.
How many total are there? It's like 1.11.
1.14, ma'am.
14, okay. Because we have
I
our test on 1.1 through 1.8 next
1.8 is all. When do you have the test?
next week, like Wednesday or Thursday.
Yeah, 1.8 will be done today.
Okay.
Okay, so basically, I would like to finish when are you having the part B of Unit 1 test? Do you know?
Part B of Unit 1 test is September 11th week. They haven't given us the date yet.
Yeah, we'll be able to complete. We'll be able to complete. After that, what happens? When is it said?
After that, we start Unit 2, but we start Unit 2 in like October.
In October. So in between, what are you going to do?
I think in between they said we have Unit 1C and then like we just have more tests. We have like a formula quiz in between and then like a project.
Oh, that's okay. Yeah, yeah. That is the time I will exploit. You got it?
Okay.
Yeah. So yeah. So that's the time we will exploit as well, but we need to be a little faster too. So, but one advantage for you guys I'm seeing is you all know limits, you all know the basics that are needed to finish much more. You see what I mean? You all know unit circles. Those are all not going to waste time for me with you guys. That we did in summer, right? So you're all on the safe end is what I'm thinking. Let's see. The last year I was not this fast, but we managed to complete. So let's see. So we want to go ahead with any questions till 1.7, guys? Any questions till 1.7? Hey guys, I'm asking you. I need to get an answer, right?
I didn't have any questions.
Okay. Okay, if you have any questions, you have to ask. Otherwise, it's very hard. Okay. So 1.8. Okay. This one is an easy topic. It comes from rational function zeros. How do you calculate the zero of rational function? That's what it is all about. So, yeah, as the more right answers I get sooner, the faster I'll be able to go. So basically it comes from algebra 2. Okay. Even the next unit will be a lot easier, but where the problem rises is only when we start the polar graphs and trigonometry. That's when it's going to be completely new to you guys. Okay. Till then, I'm sure you'll be able to we'll be able to do fast. Let's go ahead. Okay. Okay, how about this? F of x. So we are going to cover rational function zeros. Rational function zeros. Okay. So now f of x will be equal to x squared plus 2x minus 8 by 2x squared plus 4. So what are zeros of a rational function? Suppose let's say a rational function is like this. Does it have any zeros? Okay, so zeros are basically the x-intercepts. What are they? X-intercepts are points where the graph cuts the x-axis, right? So for this function, there is no zero. Zeros are otherwise called as x-intercepts. They're also called as the roots of a rational function. Okay. Now, the denominator you all know gives, what does it tell about? The denominator tells you about what and all, what are the properties that you can deduce?
You can tell the asymptotes.
Yeah, they talk to you about asymptotes, vertical asymptotes basically, right?
Yeah.
And then it talks about the vertical asymptotes, maybe the domain. You can determine the domain as well, right?
Yeah.
Yeah, it also helps you tell you about the domain. However, when it comes to determining the zeros or x-intercepts or roots of a rational function, where do you go to? How do you find the zeros or x-intercepts or roots of the rational function? What do you do? See, to find out the
You suppose
x-intercepts, what will you substitute?
Y
y is
0.
Y is 0, right? If y is 0, what happens? The numerator has to be equated to 0. That's all. So you will find out the factored form of the numerator of the rational expression. Does that make sense? So when you factorize it, it would be plus 4x minus 2x minus 8. If you understand that logic that we learned in algebra 1, right, to find out the x-intercepts, your main intent is to make y equal to 0. If you want to make y equal to 0, y is your f of x. Make that equal to 0. If you make that 0, the denominator will not be accounted at all. So you have to find the factored form of the numerator. So just join. Minus 2x plus 4. So now x minus 2 x plus 4 will be equal to 0. So x equal to 2, x equal to minus 4. So what do I get? 2 and minus 4 are the only places where the graph crosses the x-axis. Any questions? Any questions? But how do you draw this graph, guys? Do you see? The highest power of x in the numerator is the same as the highest power of x in the denominator, right? So what will be the horizontal asymptote?
1/2.
Yeah, 1/2 will be the horizontal asymptote. So one thing what we don't understand is, yes, it passes through this point. We don't know whether like this or like this. We don't know all that. However, half is your horizontal asymptote. Okay. Now, let's not get into graphing of the rational function as yet. We will, meaning you have learned it already, I know, but we'll only be considering the zeros of the rational function in this particular topic. Okay. So let's try to find the zeros of the rational function. Zeros of this rational function will be -4 and -2. Okay. And for that matter, let me show you the graph of this function as well. The graph of this function is like this. Here we go. This is the graph of this function. Any questions, guys? See, that's why we had -4 and 2. Make sense, guys? And half was the asymptote. Remember, x equal to half was the horizontal asymptote on both sides. Do you see it? So this is the graph. Subi, you never told me about your school, but I hope it's the same, very similar to the others, right?
Yeah,
Subi?
right now we're just learning rate of change and like average rate of change.
Okay. Okay, now coming to the holes, right? Let's say how to find out the holes of this rational function. Do you all remember how to find out the holes, guys? How to find out the holes?
Equate the denominator to 0.
Holes, ma?
Wait.
It is just a review, I know that, but I'm just telling you. Holes, anybody remembers?
It's just when the denominator equals to 0, right?
Denominator equal to 0 gives you the horizontal, vertical asymptotes. Numerator equal to 0 gives the zeros of the x-intercepts. Holes happen when okay, this is our rational function. Let me name it as t of x. Okay. Now, first I'll write it in factored form. What is the factored form for this? X minus 4, x plus 3. Okay. Now, divide by, this is x minus 4, guys. Okay. Now, if I write it like this, right? You write your numerator and denominator in factored form. If there is a linear factor that cancels out, that is your zero. That is your whole. That is your holes. Now, x equal to 0 is a whole in the rational function, right? If it is a whole, will the domain get affected? Will the domain get affected because of the whole? Will the,
Yes.
it will get affected, right? So now when you think about this function, right? If I graph it, right, I'll show you the graph directly to you. Okay, you don't need to draw. Okay, the graph of this rational function right now is like this. That's the graph of the rational function. Okay, so you clearly see that there is a hole at x equal to 4, right? Here. So the y value is not defined when you think through. Okay, so the domain does get affected. At that point, you don't have the graph value, right? So minus infinity to -4 and then minus infinity to 4. 4 is not included, guys, because you don't have a graph value at 4, right? 4 comma infinity. Any questions? Because of the hole, the domain gets affected. Okay. And then where are the zeros? Where are the x-intercepts? Where are the x-intercepts?
3 and 4
Assume that this got cancelled.
minus.
Whole has more priority. Yeah. So x equal to -3. Any questions? Okay, so we reviewed, what did we review? We reviewed how to find the holes. The cancelled linear factor is your hole, okay? And hole affects the domain. Literally, it affects the domain. And then you should be able to find the zeros of a rational function given. Okay, now, okay, how about this? This one you already know, guys. I want the vertical asymptote. I wanted to find the vertical asymptotes of this rational function, okay? F of x equal to 4x plus 8 by x square plus 3x minus 10. Anam, are you following, Anam? Mahir, are you following?
Yeah.
Yeah.
Okay. Coming to vertical asymptotes. Advait, I want you to be on the video. Sorry, Advait, to be very particular about it.
Sorry, I didn't realize it was off.
No worries. So, how do you find the vertical asymptote? You're going to give me all the details for this, guys. Okay, I'm going to ask you a couple of questions. Okay, given this rational function, get me the domain, get me the holes, get me the zeros, get me the vertical asymptotes. I'm going to erase the graph. The graph is not for this one. Okay, try to do this. I'll show you how to graph it in detail as well. That's right, Annam. You will write it as x equal to some value. So domain,
Yeah.
holes, zeros, and vertical asymptotes are what I'm interested in.
Sorry, I didn't mean to send it
Oh,
without
no
the
problem.
rest.
You can do slowly. That's fine. See, our intended target is given an equation. You should be able to find all the four. Next, I'll give you a graph. You should be able to find all the four. What are holes? Okay. Okay. Guys, in a graph, right? What are holes? Let's say you have asymptotes like this. Okay. A graph is like this, let's say. Okay. Let's say you have a graph like this. In this graph, this is a rational function graph, right? Holes are, let's say there is a hole in here. That means the function is not defined at that point. Let's say at x equal to, this is x equal to 1.5, let's say. X equal to 1.5, you don't have a y value. You cannot shade it like this. You got it? Meaning there is a hole there. Do you see a hole? So the graph goes till here, and after that it goes from here. There is a discontinuity there. Hole is a type of discontinuity present in any graph. Let's say there is a discontinuity here and it goes like this. So there are two holes in here. So we say at x equal to, let's say, minus 10 and x equal to 1.5, there are two holes. The corresponding y value does not exist. That's what it means, Shreya. Make sense? How do you find that? Factorize into linear factors in both numerator and denominator. The factor that cancels out is the whole. Make sense, guys? Vertical asymptote, go ahead and do. You need to be very careful on the domain part. Okay, domain, see, domain means all possible x values. What and all will affect your domain? The vertical asymptote will affect your domain. The whole will affect your domain. So the way you will split your domain is from minus infinity to whole, and then whole to another vertical asymptote. Vertical asymptote to whole to vertical asymptote, then again vertical asymptote to plus infinity. So from minus infinity to infinity, you have to find out all the breaking points. This
Is that
point,
the actual graph of it?
no. This is an example, please. This is an example. You want the actual graph? Do you want the actual graph?
No.
Okay. I didn't mean to give you the actual graph because from the types of problems would be you will be given an equation, you have to find all of this. Then you will be given a graph, you should have to be able to find all of this. Yeah, Sri Charan. Sri Charan. I don't know. I think something is wrong. I feel like the key has it wrong. I think Sri Charan, your answer is right, I feel. Oh no. I'm so confused. The opposite is what Ashrita has given. So I don't know. Okay, let's see. Navni, did you get? Okay, let
Yes,
me
I'm
see.
fine.
Minus 5. Shriya, Ashrita, I think yours are right. Something feels wrong. Navneet, zeros is minus 5. Correct. Sri Charan, you have, for some reason, somewhere you have gone wrong, Sri Charan. Shrikar, correct. Yeah. Advait, I'll go ahead and do this one. Annam, I'll go ahead and do this one. Okay. Now, how do you factorize this? So let me go ahead and factorize this function here. 4 times x plus 2. The denominator will be what? 5 and 2, right? X square plus 5x minus 2x minus 10. So 4 times x plus 2 divided by, 1 second guys. Now x times x plus 5 minus 2 times x plus 5. So I will rewrite this function as 4 times x plus 2 divided by x minus 2 x plus 5. Oh, okay. Did you see any holes, guys? I don't see any holes. Yeah, no holes. That's right. Yeah, I don't see any holes as well. Okay. So coming to this one, I don't see any linear factor getting cancelled in the numerator and denominator. As a result, there are no holes at all. Okay. Coming to, you have to determine the domain last. Okay. Unless you determine the holes, unless you determine the vertical asymptote, you cannot go to domain. What are the vertical asymptotes? Factors of the denominator are the vertical asymptotes. So x equal to 2, x equal to minus 5 are the vertical asymptotes. Suppose let's say there is a graph. X equal to 2 is a vertical asymptote. X equal to minus 5 is a vertical asymptote. 1, 2, 3, 4, 5. Minus 5 is a vertical asymptote. There are no holes, right? So you don't need to take into account. Now, what are the intervals I need to consider? Minus infinity to minus 5, then minus 5 to 2, then 2 to infinity. That is the domain. Domain is all x values. In that, what are the breaking points? This one is a breaking point. This one is a breaking point. So what intervals I need to consider in the domain? Minus infinity to minus 5. Then 5 is not included. Minus 5 comma 2 and then 2 to infinity. 2 is not included because at 2 there is a vertical asymptote. That means at x equal to 2 there is no y value defined as a part of the graph. Now coming to zeros, this has to be equated to 0. So zeros will be x equal to -2. Here is where the graph crosses the x-axis. Any questions, guys?
For domain, should you use the U to connect the
Absolutely
intervals?
yes. Sorry, yes.
Okay.
Absolutely yes. Any questions? Okay, we will review 1 or 2 problems only. Okay, you gave HA by mistake. That's okay, Navneet. Okay, now we will review. Okay, I know that everybody might have forgotten. Okay, that is the problem with this. Okay, but let's see. Now you will be finding it very easy after this. How about this? You're going to find for the next one. Okay, this one I want everybody to answer correctly. Let's see. Again, there is one more problem to do. Okay. Oh, what is this? 1 second, guys. That's better. Okay, let me write down. X square minus 9 divided by x square minus 2x minus 3. So let's consider this as h of x. Can you go ahead and find wholes, zeros, vertical asymptote, one more addition, horizontal asymptote that we discussed last week, y-intercept, domain. You know what? That's all. Would you be able to find all of these? Be careful, guys. Be careful. Next one we'll go to graph. Never mind, it's fine. Go ahead. Done, guys? Can I explain or do you want me to intervene or do you want to do it by yourself? I have not seen some of your answer. I'm a little concerned, but I have not opened it out.
Can we do it by ourselves?
Yeah.
Yeah.
If you're stuck, please ask. Don't worry about the others.
I was just gonna ask if I could have more time.
Oh, sure. If don't worry about anybody, okay? If you are in doubt, just ask. Okay, each of our paths are different. No, there is nothing wrong in asking at all, at any time, even after explaining 10 times. Yeah.
I don't know how to find the horizontal asymptotes.
What is that, Srisharan? How to find horizontal asymptotes?
Yeah, I think I just kind of forgot.
You forgot?
Yeah.
Okay, no problem. No problem. It's interesting to see. That's it. I'll definitely go over it. Oh, wow. There are so many people asking for horizontal asymptote. That's what we did last week, right, guys? Last or the previous 2 weeks, I don't know. Anyway, but that's fine. There are multiple people asking for it. So, yeah, let me go over that, okay? For horizontal asymptotes, what do you do? Remember, there are 3 different scenarios you need to consider. Okay, what you need to consider: power. highest power of numerator versus highest power of denominator. We'll take it as n and m. Okay. Power of numerator less than power of denominator. That means what? You have a function like x by x square. If you have it like this, right, meaning the highest power of numerator versus the highest power of denominator. If n is less than m, the horizontal asymptote is always y equal to 0. Why is that? Why should that happen? Let's see. X plus 3 by x square plus x plus 1. Let's say this is your rational function. When you look at it, the power, highest power of the numerator is less than the highest power of the denominator. What is horizontal asymptote? Horizontal asymptote means when x goes to infinity, what is the value that your graph tends to? When x goes to minus infinity, what is the value that your graph tends to be? That's what you're going to find, right? For that, you have to substitute x equal to infinity or x equal to minus infinity. You cannot substitute it directly. So, this is where limits come into picture. You know what I do? Limit x tending to infinity. I'll try to find out x plus 3 by x square plus x plus 1. That is my horizontal asymptote. That means I'm trying to make my x tending to infinity. But directly I cannot substitute infinity. It's so messy if I substitute infinity directly instead of x. So what I do? I divide the entire numerator by x square. X square is the highest term in this. Every denominator as well I divide by x square. So what happens here? 1 by x plus 3 by x square. Why am I doing this? I'll tell you the reason. Divide by, this is the actual scenario. Okay, you don't need to know all this. You can just memorize, but you're going to forget. Whereas if you know this, you will remember this forever. So 1 plus 1 by x plus 1 by x square. This is what you will get. Okay. Now when you substitute infinity in the denominator, 1 by infinity is what? 1 by a very big number is almost a 0. When the denominator is very huge, everything will be a 0 here. You see, 0, 0, everything will be a 0. But here it will be a 1, 1 plus 0. So the entire thing will become 0 by 1. So that is why when the power of the numerator is less than the power of the denominator, y equal to 0 is your by default horizontal asymptote. How did you get that? I showed you the example here. This is how you got it. But till now in algebra 2, you were literally memorizing y equal to 0 is the horizontal asymptote when n is less than m. That you memorized it then. But actually, what is the reason behind it? For you to find horizontal asymptote, you have to put your x value as minus infinity or plus infinity. That's what is your horizontal asymptote. You need to know the y value when x value tends to left side minus infinity or right side infinity. You cannot substitute infinity directly in any of these equations. That's why you end up dividing by the highest power of x in both numerator and denominator. Why you are dividing it? Let your denominator become infinity. Then it's easy to say that term equal to 0. That's why you're dividing. So I divided every term by x square, x square, x square, x square, x square. When I did that, everything will get cancelled because when the denominator is a very huge number and the numerator is a valid number, it's so easy because see, 1 by 1, 2, 3, 4, 5, 6. What is this? It's almost a 0. You can approximate it to 0. So this cancels. Everything will become 0 excluding this one term where it is 1. So the denominator is a 1. 1 plus anything. 1 plus all zeros are 1. Numerator is a 0. As a result, my y value would be 0. So that's why when numerator is less than the denominator, y equal to 0 is your horizontal asymptote. Any questions? Now, numerator equal to exactly the situation. What do you think will happen? What do you think will happen is the asymptote. Again, do the same thing, guys. Divide by the highest power of x. So that becomes 1 by 1 minus 9 minus 9 by x square, 1 minus 2 by x minus 3 by x square.
You
When you
just divide the
substitute,
degrees.
go ahead,
You just like divide the degrees.
divide by
The leaving the like coefficient, not degree.
yeah, the coefficient of the highest power of the numerator by the highest power of the denominator. That is your horizontal asymptote. Horizontal asymptote in this case would be coefficient of the highest power of x in the numerator divided by the coefficient of the highest power in the denominator. This too we memorized when you were in algebra 2. Now I am telling you the reason how it evolves. So this was a by b. Suppose this is a, this is b. That was a by b. So here the horizontal asymptote would be y equal to 1. 1 by 1 is 1. Now the last thing n is greater than m. That means you have something like x square plus 1 by x. If you have a rational function like this, it's so hard. You need to sit and do long division. There will be slant asymptotes. There is no horizontal asymptotes. You got it? So the thing that you need to memorize is here, this one, if you memorize it, right, if you memorize this, right, this one and this one, no horizontal asymptote when the power of the numerator is bigger. If you memorize this, you don't need to bother. But the thing is, see, you memorized it in algebra 2. Now pre-calc, everything you forgot. Whereas if you are able to substitute and try x equal to infinity, how do you substitute infinity? You will have to substitute by the divide by x square first and then substitute infinity. If you remember that, you don't need to memorize any of these. You can find out then and there. You got it? Guys, any questions in this?
Can you go over how to find vertical asymptote? Just one last time.
Yeah. Vertical asymptotes, ma?
Yeah.
Vertical asymptotes, what do? You equate your denominator to 0. Factorize the denominator, equate it to 0. And whatever x value is, that is the...
So
Mhm.
it can be 2x values then?
Yeah, it can be. Let's see. I don't know. What is this? X plus 3, x minus 3 on top. First, I'll always factorize, guys. Then it becomes easy for me. This becomes x square minus 3x plus x minus 3, x times x minus 3 plus 1 times x minus 3 I'm getting. So this would be x plus 1 and x minus 3, correct? Let me erase this for sanity's sake. Otherwise, nobody will understand anything, whatever I write. So here, this and this get cancelled. So clearly x equal to 3 is
That's
the
the
whole
holes.
expression. Yes. And then
Okay.
what else I have to say? Now, yes, horizontal asymptote is x equal to minus 1. Make sense? Did you get it? What is it? Uh-huh.
Oh, because on the bottom you did x plus 1 equals 0?
0. Yes.
Okay, got it.
What is the y-intercept? Who can tell me what is the... That is easy, guys. What is the y-intercept? It carries from algebra 1. Y-intercept means...
X equals 0.
Call controller. Y-intercept will be... to find out your y-intercept, what should you substitute?
X equals 0.
X equal to 0. If you substitute x equal to 0 in the expression, what happens?
You get minus 9 over minus 3.
9 by minus 3 is 0, 3. Make sense? So the graph crosses the y-axis at 0, 3. Did you guys get it? Can I move on?
Yeah, I got it.
What will be the... See, the domain part is the last part. Why? The domain gets affected by holes. Does get affected by vertical asymptote. So minus infinity. From minus infinity, the domain is valid. Till what point? Minus 1. There is a horizontal asymptote there. So till minus 1 is valid. From minus 1, again it goes to 3 and breaks. At 3, there is a vertical hole, you see. And then 3 to infinity. Any questions, guys? You didn't get that, Annam?
Oh no, I got it.
Okay. Akshada, did you get ma?
Yeah, I did.
Okay, Shriya, you got it, right? Advait, did you get it?
Yeah, I sent my answer. I just didn't know the horizontal asymptote, but I got it.
You got it now? Okay. For horizontal asymptote at pre-calc level, don't memorize, guys. The thing is, what happens is, because of this memorization, right? You will take the SAT after another 1 year. you will ask me again what is horizontal asymptote. But whereas if you really understand what is horizontal asymptote, when the x value of a function is going to infinity, what happens to our graph? You cannot directly substitute infinity on the x. Okay, whereas you can make your denominator go to infinity very easily. Make your denominator go to infinity by dividing by x square everywhere here. X square, why did I select x square? That is the maximum power of x in this function. If you divide by that, you will end up having some value. It can be 0, it can be 1, it can be any number value you will get based on the function. So that is your horizontal asymptote. Similarly, on the left side, sometimes it may be different. On the left side, you can substitute minus infinity and see. Same thing you will get. Can I move on? Okay, how about this? Okay, let me give you the graph of a function. This is a graph of h of x. Right now, you were given the equation. You are able to write all of it. Okay. Now, I'm going to ask you for, you're going to write wholes, zeros, vertical asymptotes, horizontal asymptotes, y-intercept, domain.
Can you make the graph bigger?
You want me to make the graph bigger? Good ask, but wait, I'm not that seriously that tech savvy to do it quickly, but I will do. I want to be, so I can do. Is this okay, ma?
Yes.
But you know what? I wrote on top of it. Okay, let me erase it, guys. Wholes, zeros, vertical asymptote, horizontal asymptote, y-intercept, and then domain. Domain should be the last one you should encounter. Ingema? Whole ruka. Whole. No. Let me know, guys. If anybody is stuck only, you have to let me know now. Should I write out the answers directly, I feel? Okay, this one, yeah. Okay. Okay. I want to show you something in this. You can do by yourself. I really want to show you another way to understand, even if it is algebraic equation or a graph, right? You can write out a sine table. Remember, where are the breakages here? There is one breakage here. You see, this is a breakage. This is a -4 point. Another breakage is 1, 2, 3, 4, 5, 6, 7. So basically, the -4 is a breaking point, 7 is a breaking point for the domain. So if I were you, I would write this table -infinity to -4. That is one interval. I want to know interval and sign of f of x. Sign table is very good always. Okay, -infinity to -4. How is the graph? It's in the negative. So sign of f of x is negative. At -4, f of x does not exist. There is an asymptote, right? -4, see, -4 till this I want to know. What is this? These are zeros, right? So I'll go ahead and try to understand whether the y value is positive or negative. This is 2 and the other one is 2. This is -2. So -4 to -2, it is positive. You see, why positive? It's above the x-axis, you see. Then -2 to, wow, -2 to 2, what happens? It is negative. The graph is under the x-axis. Then 2 to 7. What happens? 2 to 7. I should have also written, see, -2, I did not write it as a value. It's a 0. 2 is again a 0. Then 2 to 7, what happens? It's positive. Then 7 to infinity, 7 is a whole. Please, 7 does not exist. And 7 to infinity is what? It's in the positive axis. Any questions, guys? The sine table comes very handy. Okay, you should know how to draw the sine table for graphs, because when you solve it algebraically, sometimes you definitely need it to graph the rational function. So it will come very handy to graph the rational function particularly. So you should know how to graph it. So it's important that you are able to draw the sine table for a rational function. Any questions? Okay, now let me go ahead and write down the answers so that you can check as well. Wholes x equal to 7. Zeros are at x equal to -2. And what other value, ma? There are two values and 2. X equal to 2. And then vertical asymptote x equal to -4. Right, there are any discrepancies, then you shout out. Here, there are no horizontal asymptotes, I'm saying. No horizontal asymptotes.
So
Right?
if it's a slant asymptote, we just say none.
This one, is it a slant asymptote, ma?
Is it not?
Yeah, looks like it's a slant asymptote. Yes, horizontal asymptotes are none. Horizontal, yeah. See, horizontal asymptote is different from a slant asymptote. So there are no horizontal asymptote. Basically, in this case, what would have happened? The degree of the numerator would be greater than the degree of the denominator.
Mm-hmm.
Okay.
Okay.
Y-intercept is, let's say, something less than 1, maybe a 0.4 or a 0.3 or whatever. Okay. Domain is what? You need to take into account everything. -infinity to -4. Then, see, you don't need to consider the zeros. I just showed you for the sine graph, you need to take the zeros. Okay. You can just say -4 to...
Sorry, Miss Priya. I thought class started at 7 p.m.
No
CST.
problem.
What time did class start today?
5 CST. CST 5:45 to 7.
Central Time, it started at 6. Or, yeah, 6.
Oh, yeah. 6. Yes, today was 6, right? It's so much of confusion, guys. Yeah, remember last week, Anya, On the request, everybody is coming home late, right, from school. So so many of them wanted to start at 6. So we are starting CT6. I don't want to even say CST, because if you put in Google when the time changes, right, if you put CST, it's a different time. CT works perfectly. CT 6 p.m. Okay, Anya, will you note down?
Yeah, thanks.
7 to infinity. Anyway, I have recorded. Any questions, guys? Any questions? Did you all get it? You should know how to work with rational functions 100% by now. If you have any questions, you should ask. Okay, but we are very slow. Can I move on? Okay, did you all look at the 1.9? Oh, 1.9 is itself going far. Okay, 1.9, I want to finish. I don't know if I can. Yeah, we can. Multiplicity is the only thing that's extra. Multiplicity is the only thing that's extra. Did you guys have a look at binomial theorem, guys? Pascal's triangle? Okay, for next week, right? Please look at it and come. Please look at Pascal's triangle or binomial theorem. Okay, that's one subunit for you. It's
Miss Priya,
very easy.
can we like post it on Google Classroom somewhere
Yes,
so
yes, yes,
know?
yes. You are forgetting, right? Yes. Even I thought so. I forgot, but when I went through what I need to teach you today, then it occurred to me, oh my God, they'll all look at last week we discussed, so they will be looking at Pascal's triangle, I thought. Yes, Akshada, those were right. Okay, now let's get going with 1.9 as well. Okay, there's a lot to see. There's a lot. As we move on, Unit 3 will be much harder, and that's as well assessed in your AP pre-calc exam. That's why school is also going very fast. So how about this? Okay, we thought about left limits and right limits. Right, guys? We did discuss left limit and right limit already. Okay, we are going to discuss a little bit of vertical asymptotes again, but let's see. Let me go ahead and show you a graph. See this graph. Okay, I just want you to fill in this. For this graph, I just want you to fill in whatever I'm asking you. You should know the limit notation. So again and again, I will review that. This is just a review of vertical asymptotes, okay? Here, what is this, guys? Limit x tending to minus 5 minus f of x. What am I asking? What does it mean if I translate it to English as x tends to or approaches? You can use either. Approaches minus 5. What is this? What is this limit called? What is that limit called?
Left limit.
A left limit as x approaches minus 5 from the left. As x approaches minus 5 from the left. You see what happens? There is an asymptote. That's why we are discussing this. That's the vertical asymptote. As x approaches minus 5, as x approaches minus 5 from the left, f of x goes to what? F of x approaches, f of x goes where?
Negative infinity.
Negative infinity. That's all. Okay, now we discuss the left limit. This is the left limit, right? I need to discuss the right limit. Let's discuss that as well. Limit x tending to minus 5 plus. That's your right limit. Meaning x equal to minus 5 above. Right of minus 5. What happens? See? Right of minus 5. So I can write it out as f of x equal to. I need to write that. But English way of saying is as x approaches or tends to, you can use minus 5 from the right. That's your right limit, right? F of x approaches what? Approaches what?
Positive infinity.
Positive infinity. That's all. Okay. Just a review of left limit, right limit with respect to your vertical asymptotes. Okay. So we are good on that. Okay. Now, let's try this one. See, this unit becomes very easy because of limits. We already learned limits, right? So that's a big boon. G of x will be equal to x square minus 9 divided by x square minus 4. Okay. See, I really want you to be able to write the limit notation of vertical asymptote. If you're just asked vertical asymptote, it's okay. But if you're asked for the limit notation of vertical asymptote, you should be able to write this. Okay, this one is becoming x plus 2, x minus 2, right? X plus 3, x minus 3. So here vertical asymptotes are what? The graph will be like this. Plus 2 and minus 2. Right? So those will be the asymptotes. Why don't we try graphing this one, guys? I like to graph this one and see. That's an extra add-on that I want to do. Okay, how to graph this? I wrote down the asymptotes. There are no holes. Okay, and then do we have a horizontal asymptote? Yes, looks like we have a horizontal asymptote at y equal to 1. Y equal to 1, right? Okay. But unless I draw the sine graph, I will never know what happens. So I will draw the sine graph, minus infinity to minus 2. And then where are does it y-intercept, x-intercept, I would like to know. If x equal to 0, when you think about it, right? If x equal to 0, what happens? X equal to 0, zeros are at minus 3 and plus 3, right? So minus 3, then minus 3 to minus 2, then minus 2 to 2, 2 to 3. Because see, 3 and minus 3 are zeros. So I will go ahead and write all that if I want to graph. Zeros are at minus 3 plus 3. X equal to minus 3, x equal to plus 3. Right? And then vertical asymptotes are at x equal to minus 2, x equal to plus 2, no holes. And then what else? Domain, we'll write it later. Zeros, vertical asymptote. Horizontal asymptote is at where? 1, y equal to 1. All that I took into account. Now, when I write my sine table, right, for me to graph, I need a sine table. So, minus infinity to minus 3, and then minus 3 to minus 2. Then, what else? Minus 2 to 2, 2 to 3, 3 to infinity. Does that make sense, guys? So, for the sine graph, I took all my vertical asymptotes, zeros, everything into account in the domain. So minus infinity to minus 3 means, how do you find the sine graph? You have to put an x value. Any x value you can put between minus infinity and minus 3. So can I put an x value of minus 4? If I put minus 4, what happens? It becomes 16 minus 9 divided by 16 minus 4. So basically it will be positive. Any questions? Any questions? Okay, minus 3 to minus 2 means what can I put? Maybe minus 2.5. If I put minus 2.5, what happens? Minus 2.5 means minus 2.5 square is what? 2.5, right? 6.25. 6.25 minus 9 divided by 6.25 minus 4. So what happens there? This is negative, this is positive. Answer will be negative. Am I making sense? So you start with positive graph. You start with a positive graph. What happens at minus 3? At minus 3 is a 0. So it crosses the x-axis. And then minus 3 to 2, it's negative. We know that. Minus 3 to 2, it's negative. Okay. At minus 2, it's a vertical asymptote. Minus 2 was a vertical asymptote. Does not exist. Right. Now minus 2 to positive 2 I need to consider, but I want to make sure, put x equal to 0. If I put x equal to 0, it will end up with a positive number. So the graph is positive till here. Right? At 2, what happens? It's a vertical asymptote. It's a vertical. This one all comes only with practice. It's a vertical asymptote. 2 to 3, what happens? I want to check for 2 to 3. I'll put 2.5. 2.5 means again it will be negative only. So what happens? It will be negative. But there is a 3. Do you see 0? At 3 it is going to cross the x-axis. That is why 3, the value is 0. Remember, 3 is a 0. Do you see it here? So 3 is a 0. I put the 0 there. Okay. Now 3 to infinity. Let me put a 4 and see. 4 square is 16 minus 9. 16 minus 4. So that's positive, positive. Everything is positive. So it crosses it and merges to the asymptote. Am I making sense? Who did not get how to graph this? Shriya, did you get how to graph it? The sign table is your key if you want to graph it. Okay, you should be able to put out all your zeros, vertical asymptotes. Okay, those are the breakages, meaning how do you divide the intervals? Minus infinity to minus 3. Minus 3 you have to put. Minus 3 to minus 2. Minus 2 you have to put. Minus 2 to 2. 2 you have to put. So if I'm very clever, I should have showed you this, okay? Meaning you know this minus 3 comma 0 is a point in the graph before even I got started. So minus 3 comma 0 I should have plotted before itself. Minus 2 is a vertical asymptote. Minus 2 and 2 are vertical asymptote. That's why we drew this. We should have drawn this immediately. Okay. And then, see, 2 is a vertical asymptote. And then 3 comma 0 is already a point. So these 4 points already exist. Meaning 2 vertical asymptote and 2 points already exist. And depending on the sign, you can draw the graph. Did you all get it? Sahana, did you get it?
Yeah.
Okay, the limit notation here is limit extending to minus infinity g of x will be equal to what? What is that, guys? Okay. What is it? What is the word? For the vertical asymptote, I need to write. I cannot write infinity. What are the vertical asymptotes? Vertical asymptotes are x equal to minus 2 and plus 2, right? So limit extending to, how do we write it? Minus 2 minus 2 minus means left limit of minus 2. We are only considering this point. Left limit of minus 2. What is the left limit of minus 2? That means what? Left side. 1 second, guys. Left side of minus 2. G of x will be what? You guys tell me, guys. Where does it go? Left side of minus 2. Where does it go? It goes to minus infinity. Limit x tending to minus 2 plus right limit will tend to where? Where?
Okay.
Plus infinity. Limit x tending to 2 minus. 2 minus means left side of the 2. G of x will go to? Guys, you're all with me?
Infinity.
Yeah, infinity, because it comes from there, you see? It goes here. Left of this goes here. Then limit x tending to 2 plus right limit g of x will be equal, right limit of 2. Right limit of 2 is minus infinity. Does it make, Anya, Annam, Advait, did it make sense?
Yeah.
Okay, so you need to know that, okay? Now, I know you're all tired and I'll continue this 1.9 next week because see, this one is all about multiplicity. Multiplicity, and what I did not cover was we're always working on graphs and equations. I did not show you tables. If they give you tables, how will you do? They'll give you the tables. You need to be able to write the vertical asymptote limit notation. I didn't cover that at all. And multiplicity we need to go over. With multiplicity, how will you assess about the graph? Properties of the graph when there is multiplicity. Multiplicity means number of, meaning how do they make the turn at the x-axis. that we need to discuss, and then we'll jump into binomial theorem. Once binomial theorem gets over, we have to discuss slant asymptotes. Okay, I really want to complete, but slant asymptotes, binomial theorem, finish the rest of this next week. Any questions? If you have questions, you should voice out because it is going to be fast. Okay. Yeah.
Can we do one more example?
I don't mind at all. If you want to stay, others who want to leave, you can leave. The others who want to stay, I am okay. I am open to do that one more. I told you, right? You're the only class for me, and I'm okay to do that more problems.
Priyanti, I'll watch the video,
Recording. Yes,
but
I
I
know that
have
you have class.
practice.
Yes, I know.
Yeah, okay.
Okay, we can do one more problem. I'll go ahead and do one more. We'll do what? I don't want to go to new topic, right? So let's do one more problem. Okay, wait. I gave you. Okay, let's see. Can I erase this one? We are going to write out limit notation for vertical asymptotes given a graph. We will do one more problem. Just wait. I have to pick up problems for you. 1.9. Okay. How about this? Let's write down for this one. Shall we write down for this one? Yep. Graph is given, right? Also, yeah. This is what I was about to discuss. I didn't discuss. Let's do both the problems if you're all okay. If you want to leave, leave, guys. There is no hard and fast rule for you to stay. You see, at the level of you're all in high school. So if you want to stay, if you feel like learning, or if you already know, you can log off too. How about this? Limit notation of vertical asymptotes. What do we do here? Let's see. Here, what is the vertical asymptote? -3. It's -3. Here it is a 5. Right? So, let's write down the limit notation. Limit, first you need to write down the left limit, right? X tends to left limit of -3, -3 minus. The other one is limit x tending to -3 plus, meaning -3 is your vertical. If they ask you for vertical asymptote, you will directly write x equal to -3 and x equal to 5. Okay, so those two are the vertical asymptotes. But when you're asked for the limit notation of vertical asymptote, you need to write all the four, basically x tends to -5 minus limit x tends to -5 plus. So you're going to write f of x goes to what? F of x goes to what? Here f of x goes to what? F of x goes to what? Goes to what? -3 minus means what happens? It's going to infinity. -3 plus minus infinity. -5 minus, it's at a minus infinity. -5 plus plus infinity. Does it make sense? Anya.
Yeah.
Okay. This one is a little different. What is the vertical asymptote here? X equal to 2, right? So this is going to be the vertical asymptote. But the worst part is, you know how to graph it, guys. You can type in the equation. Okay, and then the table set, you can go and say ask. Right, guys? You can say ask. You can set one of these to ask, right? So these are your values. Let me give the values for you. Okay, instead of the table, you know what I'm going to do? I'm going to erase the first one off. Okay, so I'm going to give you the values so you can evaluate and tell me. See, these are the values. Okay, you will be able to get this from a calculator. That's what is required out of you. This I was about to teach you next week, but I thought I'll just tell you what it is. So x equal to 2 is, if they ask you for the vertical asymptote, you'll write x equal to 2 clear. X equal to 2, correct? Yes. One second. What? X equal to 2 is your vertical asymptote. Sorry guys, I gave you the wrong table, I think. Very sorry, I didn't mean to. Okay. So that's your table. So how will you write the limit notation? From here you need to see and write the limit notation. What are the limit notation you'll write? X tends to 2. So 2 plus 2 minus. Left limit, right limit. F of x equal to, you'll write f of x equal to. So go ahead and check. 2 plus means what? What do you think 2 plus is? Quick, you can say now. What is 2 plus?
Infinity.
This is plus infinity. This is infinity. Did you all get it based on these two values?
Yeah.
Class and solid. Okay. Yeah, this one is easy, but table definitely you need some inputs before I assign. But I'm going to assign both 1.8 and 1.9. Okay, guys?
Wait, Miss Priya, I had one question. At school tomorrow, we're doing something. It starts with like polar. I forgot what it's called, but can you just quickly tell me what it is?
Oh, polar graphs.
Yeah.
Your school is okay. I don't know what to do with the sequence. Okay. Polar graphs are, see, okay, let me show you. Just let me delete this off. Okay, ma. See, you're going to start polar graphs tomorrow, huh?
I don't remember if it's like tomorrow or Monday, but we're
See,
starting at
but you
1.
attended the summer class, right?
Yeah.
You attended the summer class. So you know the angles, right? You know these angles, right, ma? What I'm drawing. You know these angles, right? You know these angles, right, ma? Pi by 4.
Yeah.
This one. All that stuff you know, right?
Yeah.
Yeah. So basically pi by 4 and then this is pi by 2. This is pi. This is 3 pi by 2. All this stuff you know, right?
Yeah.
Yeah, so this is 30 degrees. Let's say, okay, we'll go in degrees now. 30 degrees, 45 degrees, 60 degrees, 90 degrees. Then you go with 90 plus 15 is 115. Then what is it now? 165, 30 degrees, right? Okay, 150. Then this would be 30 degrees less 120. This would be 90. Something feels wrong to me though. Okay, something feels wrong. 90, 120 is here,
I
130.
think you messed up because it's like 45. So that's 135.
135. Okay. Now the thing is, in polar graphs, what happens is you have circles all around. Okay, this is a polar graph. You got it, huh? Now the thing is, what is this point? This will have 4 ways of denoting it. Okay, since you already got introduced to this radians and degrees, it's pretty much easy. Okay, see, this one is radius 1, radius 2. So this is 2 comma 30. Like x comma y in polar graphs, you have r comma theta. Make sense?
Yeah.
Did it make sense? So 2 comma 30 is the same as what happens? If you go like this, it's 30 degree. If you go like this, what is the angle there? 2 comma
Negative.
minus 270, 330. You got it?
Yeah.
The same, you can write it out as minus 2 comma 30 as well. You get it? Meaning, no. There are 4 ways of denoting the same point. One is 2 comma 30. The other one is 2 comma minus 130. Do you get it? One is the positive angle, one is the negative angle. You can denote it. Make sense?
Yeah.
Yeah. Similarly, you can as well denote it in 2 other ways. So this is all about polar graphs. You got it, huh? Entirely, it's new set of graphs you will be discussing.
Okay. Yeah.
Did that give you an insight?
Yeah.
Okay, but we will cover it only a little later, ma.
Okay. Yeah. I
Okay,
think we're
maybe
just starting tomorrow and then like coming back to it after a bit.
yeah. See, yeah, but you know what? Your input on the radians will really help you. Radians, degrees around the negative angles, all that you know already, right?
Yeah.
That will really help you, I promise. But
Okay.
we will come to polar graphs only a little later, ma.
Okay. Yeah.
Yeah. Okay, ma. Okay, bye-bye.
Yeah. Thank you, Miss Priya. Bye.
Bye.